Why are we limited to 104 keys that serve only one function each? 104 might sound like a lot, but we found uses for each and every one of them, especially those that are reachable. That means if I want to speed up my workflow, I have to memorize some overly long combination of keys, or I could just create more of my own. The Elgato Stream Deck is probably the most famous macro keyboard. It has one pretty big issue though, it's $80 for 6 keys. Surely I could do better than that myself. Since I had the power to customize my new control deck, I put 6 keys and 2 knobs on it to make my keyboard officially better than the Stream Deck, to make me better than Elgato. I wanted to try linear key switches as I already have tactile ones on my keyboard right now. I chose Cherry MX Blacks as they were pretty cheap at only $1.90 on DigiKey. I also had a Pi Pico already lying around, but you can get one for $6. I also chose right angle potentiometers, though they've got up in price from $3.68 from when I bought them to about $4.50 now. I have created a spreadsheet with all my parts and all their costs and put it in the description, as well as a GitHub to host all my files if you want to download and modify them. First, I set out to create a basic concept. I started working in Blender and I designed this. I then realized that this would be a perfect opportunity to learn a more engineering focused software like Fusion 360, so I completely restarted. Before that, I knew that I wanted to use a PCB for the control deck as it would make soldering a lot easier, especially for a somewhat beginner like myself. I used Eagle to design the PCB using the measurements from the Blender design. However, one thing that I didn't notice is that at some point in Blender, I scaled all the keys by a negative value, which meant that the switches were all flipped. This meant that in the PCB, the holes weren't actually in the right place. Luckily, I could just flip the PCB over, but this almost cost me. Another mistake I made was that I didn't include the microcontroller in the PCB design itself. This is because I thought I could just solder the wires from the PCB to the microcontroller after, but this made it a lot more complicated and introduced a lot more error. If I just added the microcontroller into the PCB in the first place, it would make the design a lot simpler and a lot sleeker. Despite all this, the PCB design was complete. I used PCBWay to order it, and it came pretty quickly and was pretty cheap. It was about $5 after coupons for 5 copies of the PCB, so I knew that if I messed up, I'd have some extras. The only issue is that to qualify for the coupon, the PCB had to be less than 10 centimeters by 10 centimeters, but that didn't affect me as much as my other mistakes did. Back to Fusion 360, I created the enclosure around the flaws in the PCB, and this was definitely a good idea, as if I printed it before receiving the PCB, I would have had to throw the whole thing out and start again. That would have wasted a lot of time and a lot of material. It has holes in the walls for the potentiometer and the pins to keep the PCB in place. It also raises the PCB slightly to ensure that the extra solder doesn't make it uneven. Printing the enclosure took a lot of time, but you're not getting a print time lapse because I'm not a real YouTuber. After printing it, I added these 2 blocks to hold the Pi Pico in place. The first one makes sure that it doesn't move side to side, and the second one makes sure that it doesn't move back. This is so while plugging in the control deck, the Pi Pico doesn't get pushed too far in any direction, making it unreachable by the cable. There were 2 issues at this point. The second knob and the 4th button both didn't work. I was going to leave them as they were, but I decided that I should at least try my best to make sure the control deck works as best as possible. So I picked up the soldering iron again, and I resoldered the wire for the 4th button to the PCB, and it worked. I did the same for the second knob to the PCB, and even though the soldering job was absolutely terrible, it still worked. It obviously doesn't look as good as the others, but nobody's seen the inside anyways. I used CircuitPython to code the microcontroller. The potentiometer changes the volume, and the top 3 keys can go back, pause, or go forward as they're the media control keys. The bottom 3 keys I've mapped to Control F1, Control F2, and Control F3, and these I will then map to whatever I want in whatever program I want. In Blender, I've mapped these to Save File, Render, and Apply Bevel and Subdivision Modifier. These are all 3 buttons that I need in my workflow, and the last one especially took way too much time for this. I mapped the second knob to switch between views in Blender, and although it might not save me time, it's still really fun. This is basically all I needed from the control deck, so I'm pretty satisfied with this. The media keys are definitely a lot more convenient than pressing Fn and F12, and they also mean that I can get a smaller keyboard without losing media key functionality. Although the other keys I haven't spent a lot of time with, I still feel them making my life slightly easier every time I use them. This means I can finally get back to doing what I really want to do, which is creating stands for my NBA Funko Pops. It's definitely not perfect. While a second potentiometer still technically works, I feel like it's just a matter of time before the terrible soldering that I did comes back to break it somehow. I've been looking into a screen to put at the top of the control deck to show what song is playing, but that would require either a new PCB or some risky soldering, so maybe that's for another time. As for my first real completed electronics project, I'm pretty proud of what I was able to get done. If you have any questions or suggestions, feel free to connect with me on LinkedIn or on my website. I'll see you for my next project, which will hopefully be in less than 2 years this time, and bye.